Осталось сейчас. Ну, технические вещи.
Being a mathematician is not you're not understandable by your friends, by your family, by your wife. It's not an easy thing.
Horstman committed suicide. Marcatz had all his family killed in the war. Turing committed suicide after the English government punished him for homosexuality. Nash spent 30 years with mental illness, strong. But Maxwell was fine. So you see, there is no fatality. What is similar, on the other hand, is the idea of the basic idea of the cooking. You put on the fire, you have to mix and wait for the reaction. When you work on mathematics problem also, you put together all the ingredients and you mix and you mix and you put together and you mix and you mix and you mix. You wait until there is a chemical reaction between the ideas. It all comes together in the good way. And you go on.
Attention par contre au-dessus, hein, l'assiette est très chaude.
Non, c'est un piège.
Faites attention, hein. It's very very hot.
And after reading, I will take you back for a short while in the wonderful world of mathematics. And water comes out in the form of vapor. Why has it transformed from liquid to vapor? Just heating. This is such a puzzling mystery. You can abstract this in its simplest form in a mathematical problem, replacing the complicated water molecules by just small balls, which extrude each other, like billiard balls, and still you get a phase transition. People did not expect this when they started this, in the 40s, in the 50s. They started the numerical simulation. They found a transition. They were amazed. Phase transition, you can formulate it as a mathematical problem. We observe it every day, but we cannot explain it. We don't understand. It's a monster problem. Ouais, du verre peut-être.
Ou de l'ambre.
Ou de l'ambre.
Et je vous fais un truc un peu plus gros en verre de Murano. Et après là, laisse refroidir, laisse en liquide et ça de l'autre côté.
Ah oui, d'accord.
C'est un village médiéval très beau. Non, il m'a dit dans le congélateur.
D'accord. Ah oui.
Ouais. Oui, là,
Okay. Imagine I put a lot of gas here and vacuum here. And then, at the beginning of the experiment, I remove this separation. What will occur? Gas was here, there was no gas here, but then the gas will go from here to here and it will invade.
Для геликоида Прямые, которые поднимаются вверх, пересекают все время вертикальную прямую. Очень хорошая лестница. Я хочу показать студентам приятные вещи. Ну вот, несколько работ, которые связаны напрямую с темой нашего разговора о математике и исходных задачах. Все началось с того, что я был еще студентом, и вместе с замечательным математиком Дмитрием Борисовичем Фуксом мы писали книгу по топологии. Вот это одна из первых моих работ на эту тему. Так началось мое увлечение такой математической живописью. Как показал опыт, студентам это очень помогает. В книжках это очень выгодно для быстрого понимания материала. Ну и с тех пор часто я и мои коллеги используем эти работы для того, чтобы студентам быстрее объяснить довольно сложные математические конструкции. Вот еще одна работа из самого первого цикла моих графических работ. Это яркая иллюстрация, так называемое, на таком жаргоне нашем профессиональном, действие фундаментальной группы на высших гомотопиях пространства. И эта группа переносит как бы на себе элементы других групп высших гомотопий. Вот тоже очень наглядная и очень содержательная иллюстрация. Это так называемая периодичность Ботта. Для меня все эти работы это не просто некая игра ума или там, игра карандаша или пера с тушью. Это некие фотографии математического мира. Мне так повезло, что я мог в него проникнуть, и обладая некими способностями рисовать, я могу его изнутри фотографировать. Все для меня фотографии некоторого очень увлекательного, существующего вне нас мира математики. Есть люди типа спортсменов. Спортсмен, он делает рывок, он на старте и бежит быстро. Но это тип интеллекта, он задачу делает быстро, стремительно и эффектно. Есть люди, которые устроены наподобие рудокопов. Начинают копать, долго возиться, глубоко лезут в землю. Я, может быть, скорее второго типа человека, чем первого.
One mathematical question that is associated with the process of olfaction or smell is the question of how one can decide which fish are in the room based solely on the combined scent of all the fish. So if I stand in the center of the room and inhale, and the sense of smell is very primitive because you can imagine that very, very early in evolution, the most basic primordial organisms needed to be able to sense the chemical composition of their environment. So sensing what types of chemicals are around that ability is in some way the very first type of sensing that evolved long before touch or sound or sight. The arena of smells, the set of smells that someone encounters on a daily basis, is not organized in any obvious way, and somehow your brain is able to decode all of these odors. One of the a typical solved mathematical problem is called the cocktail party problem, and The cocktail party problem.
They just move a lot, but actually they don't move at all. They just remain on the same spot. And the mathematician which I was just made the mental experiment. Let's take one of them and push it. Just give a tap. And then he will just start running. Maybe lose the weight that now for the moment maybe they are not losing anyway. This is a movement of a single particle which goes in a very regular fashion. Now, here is another sort of motion. I just throw these particles together. So this describes again the motion of very erratic objects, little objects interacting with each other. These are two kinds of motion. The first one is more or less describes the motion in classical mechanics. The second one describes the motion of microscopic particles, the so-called Brownian particles. So what I try to do is understanding the interpolation in between. How is it possible to describe mathematically moving from a regular, very regular motion to a very erratic one? So let's take Brownian motion and let's, in some sense, slow it down. The point about doing this is that it's much easier mathematically to understand this dynamical system in a way than to understand these very complicated dynamics. That's why you do this. You try to express something complicated in terms of something simpler. The interpolation is not a physical one, it's a mental one. It's a way of effectively building the bridge between these two kinds of objects.
Sur le pont d'Avignon, l'on vit danse, sur le pont d'Avignon, l'on vit danse tous en rond. Sur le pont d'Avignon, l'on vit danse, sur le pont d'Avignon, l'on vit danse tous en rond.
At least I knew that in mathematics, again, I could just explore words, open new bridges if I could, and without having to ask the permission and authorization to anybody. So I think that it's basically, a feeling of having absolute need of internal freedom. Life actually, for various reasons, I decided at some point that mathematics was not for me. I decided to leave university, and this was after May '68, and I went to the real world in some sense for 3 years, and I experienced it, and I found it so boring.
Fremd ich in sein gezogen, fremd sieh ich wieder raus.
Unfortunate that I cannot sing better, but on the other hand, in a certain way, at least for me, my way of doing mathematics, I think, is also a way of singing my way out of life. That is, everybody does what he can. And I chose this way. The beauty, I think, and the tragedy of mathematics is that you ultimately need to be able to communicate part of the excitement, part of the beauty, and also be ultimately modest with what you can do.
У него вопрос, который понять уже много лет, что такое, если этого не коммутативный вариант. Рассказать по этому поводу.